Good morning, everyone. Really happy to see so many people here. I'm really happy to be back in Oslo. This is truly one of the best conferences to go to in Europe. And to show our appreciation before we get started, could we please give a round of applause to the organizers? Thanks. This is also going to confuse everyone else that's not in this room. All right, so this is about what's new in C#, some of the features that have been added the past few years, or actually the past decade, and also some of the things that we are going to expect in newer versions of C#. I usually joke and say that C# is turning into F#, and I'm going to stop making that joke because the truth actually hurts quite a bit. But in all honesty, C# is taking inspiration from so many different programming languages. Not only F#, but also Java, Kotlin, Swift, and all of the other amazing programming languages. But what they are doing with the language is that they're making it a part of C#, so that we as C# developers are familiar with those features. So my name is Filip Ekberg. If you do have any questions after this talk, send me an email. It's funny, no one told me that I forgot to put my email on my slides. I've been telling people to email me for years. I never received any emails. But now it's up there. Send me an email if you have any questions. So C# has gotten all of these amazing language features added to it in the past decade. Things such as generics, async and await, and pattern matching are some of the things that architecturally change how we look at our solutions. We can architect our applications a little bit differently to make them more readable, more maintainable, and honestly a little bit more fun to work with. While we're not going to be able to cover all of this here, I just got out of a 2-day workshop going into detail on all of these different language features. So we're not going to be able to cover everything in depth, but I'm going to give you some inspiration to what C# has been improved with over the past few years. And what's interesting with C# and also VB, if you like that programming language, it's all open source. You can go onto GitHub and you can participate in discussions around what to get into the language. You can ask the language designers why they would want to add some certain features, and you can also see what other developers are expecting from these features. So not everyone knows that C# has been open source for quite some time, so it's easy to follow along with the progress of the language. They've done all the things such as records, pattern matching, all of those improvements have all been done through GitHub. Open discussions, getting inspiration from other programmers out there that are using the language. Because honestly, if you build a product, if you're not getting some feedback, it's really hard to know if people actually like what you're doing. And I'll show you this later, but there's one language feature that they added into C# as a preview feature, and then they got a lot of community backlash. No one wanted this language feature, so they removed it. Funnily enough, everyone at Microsoft thought that this is going into the language. Everyone was using the preview version and added it to their repositories. So all of a sudden, everyone had to go back and refactor their application a second time. So don't always jump on the preview features. So if we want to use the latest version of C#, how do we do that? Now, some of the language features require a particular runtime. For example, C#8 requires .NET Core 3.1. If you want to use C#9, that's .NET 5, and so forth. Now, this is because some of the language features require things in the runtime as well in the .NET SDK. I tend to say in the framework, but it's very confusing because there's no longer any .NET framework. Now, if you require some of the language features that also require a runtime change, you will have to have both of course, the compilers as well as the runtime installed. And you get that with the latest version of Visual Studio. But an unsupported feature of this is that you can, in fact, use a C#12 feature, for example, that doesn't require a runtime or .NET type. You can use that for older versions of .NET as well, because it all just is compiler magic, or it just uses compilation to translate this into the IL, which is then also compatible with older versions of the runtime. So that's quite cool. So with that being said, we're going to be looking at quite a lot of features from C#8 through all the way to C#12. But before we get into C#12 and what's coming in the future, I want to talk about some highlights from C#8. There was quite a lot of language features added to this iteration of the language. Now, you would imagine that once you've gone to the 8th iteration of your product, you would be finished. That's not the case, and if that was the case, I wouldn't be standing here. So some highlights from C# 8. They introduced a true way of you doing read-only members. You can have default interface methods. And we're going to look at a few of these in just a moment. Switch expressions, which is pattern matching enhancements. Some using declarations, static local functions. There's a lot of things that was added in C# 8 that will help us express ourselves a little bit differently. I've highlighted a couple of these here, which are the important features. Pattern matching enhancements using what's called switch expressions, which we're going to dig into. We're going to look at some nullable reference types and asynchronous streams. This is just to get you up to speed about what's added to C# over the past few years. Before we talk about the useful features, there's one feature called default interface methods or default interface implementations. I normally say that this is dividing developers into two groups. Some people love this feature. Actually, I haven't met anyone that loves it, so either you hate it or you just don't like it. So with this feature, look at this interface here. I've deployed this to all my users. I have 1 million users on GitHub that's using my interface, and all of a sudden I want to extend this with more methods. If I do this, if I add a method to this interface, everyone that's using my package will then have to implement that new method, which is a little bit annoying, especially if you're a library developer. So what's the best way to fix this? Why not allow you to actually have a method implementation on your interface? So while I'm using an expression bodied member here to create this method implementation, this could have been a normal method body. So now my interface knows how to execute code. And obviously this requires a runtime change, because previously no one expected that an interface, which is a contract, would be able to actually execute some logic. So this is good if you're a library developer. I've seen people use this to introduce converters and whatnot. I'm not sure if this is the best approach to introduce a helper class or doing multiple inheritance, but it's there. Now, in terms of useful language features, there's this thing called nullable reference types. So in C# or actually in all other programming languages, we've all probably experienced this. If you haven't, welcome to the world of programming. This might be your first day. Tomorrow you'll get this. But in all honesty, if they were to rebuild the compilers today, just throw everything out of whatever's there in Visual Studio and introduce C# as a new programming language, they would make it really hard for anyone to use nulls. They do this in Kotlin. In Kotlin, you have to explicitly say that I want this to be null. I want to allow you to use nulls for this thing. And the compiler is going to smack you on the fingers and tell you to not to, because it's not a good idea. The problem with nullability is that we'll end up having null checks all over the place. It's going to clutter the code with unnecessary if blocks or unnecessary question marks or exclamation marks in the case of C#. But also, what does it actually mean to return null from a method? As an example, if I have a repository that fetches a user from a database, that returns null. Did that mean that I couldn't find the user? Was the user deleted? Did I get an exception? Personally, I always return null, so I should probably listen to my own device here and not do this, because it's very confusing. It might make sense the first time you write the code, but in the long run, it doesn't. So instead, a better approach would have been to introduce standard objects or default objects. For example, you inherit from the user and have a not found user or deleted user. And you can then use pattern matching to determine exactly what that user is. It's better. Similar to nulls, but it's at least a little bit more understanding what you're doing. And also introducing nulls in the language means that we encourage objects to be mutable. That means that we can change the state. Once I create an object, I don't want that to be changed at any time without it being dereferenced, because there's going to be some issues with multi-threading. If you're building multi-threaded applications or applications that get data at the same time from different places, then you might end up having race conditions, and if you have objects that are not immutable, you'll end up having some issues. So we can fix this. We can, of course, look for nulls all over the place, but this here is ugly. And someone's going to tell me, well, you can write this much better. Obviously, I can write this if statement a little bit nicer, but introducing question marks all over my code base, it's not really the best architecture or not the best approach. While it's obvious what I want to do here, it's not very, very nice. How about if I tell the compiler to treat all my nullables or all my reference types as being not nullable? So what does that actually mean? It can enable this feature in a couple of different ways. So traditionally, this is a normal C# application, but traditionally everything such as an IEnumerable or a normal string, they're all nullable. And this application doesn't give me any compiler errors, it doesn't give me any warnings or anything like that. But when I enable this language feature called nullable reference types, I can say nullable, enable, and now all of a sudden it's going to tell me or give me a little bit of a squiggly here telling me that you have a little bit of a warning here. We all know that as soon as we get a warning in our compiled application, we go and fix that. Everyone that's laughing, you don't do it. I know. I'm the same. I just ignore all the warnings. There's a fix for that as well. So I want to enable this instead of doing this per class. Like, it's a good option to be able to, if I want to refactor an older version of my application, I can go ahead and enable this for a class, a method, just a field if I wanted to do that. But honestly, what I want to do here is that instead of doing it per line, I want to go into the project file and say that I want to enable this language feature. And now I've enabled these nullable reference types. And I've also enabled another thing called treat warnings as errors. This is probably the most amazing thing that you can do in a project. So if I save this here, and I go back, and all of a sudden we have nullable reference types enabled, and instead of getting a warning, I get a compiler error. I can no longer compile the application because I haven't guaranteed that this is set to an instance. Now, nullable reference types in this type was introduced in C#8. There's a lot of improvements to how we work with this coming in C#11 as well. But let me get to that in just a moment. To get rid of these compiler errors, we have to guarantee that this is set to an instance. So I could, of course, introduce a constructor. And now if I do that, it's going to tell me that, well, the constructor of a class should be in charge of instantiating these objects. The problem with then changing this, first name, string, last name, I'm going to set these to the corresponding values. Let's do last name. And now I don't have any errors anymore. But then when I compile this application, everyone that's using this class is now going to be incompatible. Not the best approach. So we have two options. I really don't want to introduce a constructor. And I'm going to get ahead of myself here and show you a language feature of C#11 that allows us to get around this problem. I can say that this is required. If I can spell this, there we go. I can now say that anyone that's creating an instance of this has to set this value. And they can do that in the object initializer, which is very different from introducing a constructor. Because anyone that's deserializing this, if you're using system.text.json, which is the built-in JSON serializer in .NET, it will look for required properties, and if it's not available in your JSON that you're deserializing, you'll get an exception. If you're trying to create an instance of this class without setting this first name in the collection initializer, it's going to tell you that you have a problem. So if we require this here, and you might have also spotted that I have another keyword here called init only. This is from C#9, where I say that you can initialize this, but you can only do it once. So after that, this is going to be immutable. So we require to set this, but then you cannot change it. I could set it to set, and then it's no longer immutable, but that's not a good idea. So I want to require the first name, but honestly, I don't want to require the last name for some reason. So there's a few different ways to solve this as well, but I just want to allow this to be set to null, and this is the nullable reference type. I can now say that a reference type is allowed to be set to null, so you introduce a question mark. All right, so now the problem wasn't really in this class. The null reference exceptions would have occurred where someone uses this class. And that would have been, so let me just do the same thing for where this class is used. This wouldn't be set to a null reference exception either. This wouldn't throw anything. So I'm going to say that I allow this class to also be set to null when you instantiate this person class. Now, if I expand this method here, I know that this here gave me a little bit of a compiler error as well. So the compiler is really smart here. It knows that you have something that could potentially be null. And I can say that, well, I want to perform a null check. I know that details can be null. This is a nullable reference type. Last name can also be null. And then all of a sudden, I've performed the appropriate null checks. Without enabling this language feature, I wouldn't have known that this would have been a potential null reference exception. But you don't have to end up doing question marks all over the place. Can also, the compiler is really smart. It introduces something called null state static analysis, so that it keeps track of if you've performed a null check. So I could say, well, if person.details is null, continue. If person.details.lastname is null, continue. And then it knows that I've performed these appropriate null checks. And of course, we could write this in many different ways. But this is just to illustrate that it's not going to complain about details here. Because if I don't do this, it will probably complain that I'm not doing the null check here. So now I can do this in many different ways. It's a quite powerful language feature. But it also knows that if I perform the null check in another method that I call, and that method can then promise that it's performing the appropriate null checks. So an example of that would have been to say, there's a class called argument null exception, throw if null, and I can say person.details. And we could do the same for the last name. And now it knows that this method promises that if this is null, it's going to throw an exception. So it validates this input argument and then tells me if there's an exception, or there's no null references. Compiler's doing a whole lot of smart things here. So I know a lot of people that enable this in their projects, and they find a lot of potential null reference exceptions, which is better to do in compile time rather than in runtime. There's another place in this application. Before I get to that, let me show you another option here. If we remove this, I could also say that I'm smarter than the compiler and say that I'm going to, dammit, give me the details. This is the dammit operator. You think this is a good idea? Maybe. This was a fix to get rid of not having the required keyword previously in C#10. So you could say that I require this to be non-null, but the default is null, dammit. Not the best design. Anyways, let's keep it like that for now. And then instead, we're going to go down here and see that there's another problem. I'm saying that this here requires that I return an instance of something that implements IEnumerable. I could say that it's potentially null, or that it is contains potential null references. And in C#13, you'll be able to do question marks, exclamation mark all over the place. And it will just write the code for you. I'm kidding. So I don't want to do that. Honestly, that is the last resort. Allowing to return null is just to be able to get this into an older application, but doing this from scratch is probably not the best idea. So instead, I want to ensure that I've created this instance. I can do that by saying I want to yield return something. I can do yield return. That means I don't have to create a temporary list. I can use the target type new expression to tell me, just create a new person. So the compiler will use this new language feature called target type new expression to figure out what type it needs to create and then give me an instance of that. Because I'm not required to create the details class, this is not going to give me an exception. But look at what happens if I say I want to also create a new instance of details. Now it's going to give me a compiler error here because I haven't set the required property of first name. So I can do that as well just to illustrate exactly how this works. I can say first name. Oh, look at that. I'm going to indent this a little bit nicer. It even tells us that first name is required. So Visual Studio will tell us that you are required to set this to an instance. Right? There we go. Set it to an instance. Probably not the best idea. So while you think you are smarter than the compiler, you're most certainly not. Therefore, we should set this to some default value. Maybe we do string.empty instead if you want to do that. You get the idea, right? So we could set it to a default object instead, which is not null. So the nullable reference types allow us to quickly find places that could potentially cause exceptions. And we can enable and disable this. I can't only enable this, but I could say that nullable disable for this method if it's causing a little bit of nuance in my upgrade, or I can enable it for certain portions. All right, so with that being said, I do recommend that you turn this feature on. And while usually I joke and say, you should turn this on and check in your code and just leave work. You should actually try this. It would be such a fun social experiment. Turn it on and just check in your code and go on vacation. Someone will fix the code, I promise. So with C#8, we also got this thing called asynchronous streams, which is a quite powerful language feature. It allows you to consume and produce streams of data. I have a talk later today on building asynchronous programming in C# and doing that efficiently. It's at 3 o'clock. So we'll quickly just go through exactly what this language feature is doing. Basically, I can consume a stream of data like this here. So what does it actually mean to then say, I want to await a for each loop? Let's jump over to Visual Studio again, and I have a sample for this. So what I can do here is that I can say, I have this await for each that's going to retrieve elements asynchronously. So to create one of these, it probably makes more sense if you look at how to produce a stream of elements. I have a method called readAsync, which is going to produce an iasync enumerable of string, which means that it can give me strings on the fly. Basically, it could be retrieving them from a message bus, let's say an Azure message queue. Could retrieve it from a disk, memory, whatever. Doesn't matter. The idea is that I get one element at a time. I don't know how many I'm going to get, but as soon as I get the elements, I'm going to be happy. And this is, of course, marked as being async. I'm using a language feature from C#8 called using declarations. So I can say using var stream. This means that once this method all completes and finishes, it's going to dispose of that disposable type. So I no longer have to wrap my entire code inside a using statement. And then I have a while loop here that's saying I want to read the next line from a file on disk. I'm using pattern matching, which we're going to talk about in just a moment, to say that as long as this is an instance of a string, I'm going to capture this in a local variable, which is only available inside the scope of this while loop. It's quite handy. The previous versions of C#, if you did this in C#8 or C#7, you'd have to write a little bit more code than this here. So not only does it validate that it's set to an instance, it also captures this into the local variable called line. I can then say I want to process this line. This might take some time. It might be sending it off to another queue and waiting for that response, might be storing it to disk or whatever. You get the idea. It's an asynchronous process that takes a little bit of time, doesn't matter what it's doing. And then I use yield return. Now yield, together with the iasync enumerable, is what's making this magic work. So this here will indicate to the iterator that there's now a new element available to process. And honestly, the async and await keywords, together with the iasync enumerable and yield keyword, there's a lot of context switching and jumping between threads. And to make this work, it's really quite amazing. So now this produces a stream. Now, normally, you might use a producer like the Azure SDK, for example, to say, connect me to a message queue. So maybe you don't write this portion of the code, but you do write the consumer part of things, which is this await for each loop. What you might have seen before is that you say, I want to iterate through all the elements available in this chunk of data. So when you have await in front of something, it means that give me all of that, all of the result when you're done. The await in front of the for each loop means that each element is going to be retrieved asynchronously. So I can put a breakpoint in here, and I'm just going to print that to the console. If I put a breakpoint here, I'll put a breakpoint inside the while loop. And I'm going to run this with the debugger attached, just to make sure we run the right project. And you'll see here that it starts reading one of the lines, and then we get up into the for each loop. It processes this. I could choose now to not continue, break out of the loop, and that would stop reading from the stream. But then when I want to read the next element, it goes ahead and reads that, comes back to my for each loop when that element is available. So if I release this here is going to show you my favorite song. I'm sorry. Not really. All right. So that's the asynchronous streams. They're quite powerful, and I'm using this together with that pattern matching enhancements as well that we're going to talk about next. So there's a lot happening in this code snippet here. Even though it looks very simple, there's a lot of code generated to make this work. The task parallel library to get with the generated state machine, it's doing a lot of things internally. I'm just happy I don't have to write that code myself. So also with C#9, we got a thing called records. Now records is another way of creating a reference type. This was one of the language features they wanted to add when they started the work on the open source compilers. But apparently it was very difficult to get this language feature created and added to the language, so therefore it took a little bit of time. And one of the things you'll notice with the work on all of these language features is that they want to make it a part of C#. They want to make it feel like it's meant to be a C# language feature. Although, if anyone in here has ever done C#1, it's very different today. But it keeps improving with every version of the language, and it feels like it belongs in the current time. We looked at the init-only setters, which is a way for us to create a immutable or set only once setter on a property. We have something called a top-level statement. We have pattern matching enhancements in C#9. There's this target type new expressions, which I showed you just a moment ago. And there's a whole lot of more language features that are more important if you are working with very low-level programming. There's some caching going on as well. There's a whole lot of language features. Like even if this is the 9th iteration of C#, we're not going to spend time looking at all of these here because some of them are just important for very specific use cases. But what we are going to look at is how to use record types and pattern matching. And I didn't say this, but we also have this language feature called top-level statements. And let me show you this here real quickly. If you haven't seen this before, this here is actually a normal program file. So I don't have a public static void main or anything like that. This here is the new style of writing a console application, for example. But it's also what you use if you want to create something called a minimal API. So there's this new concept of allowing you to quickly create a web application that only lives in a console application like this. It's very simple to read, and it's quite powerful. So with that being said, we're going to be talking a little bit about pattern matching. So pattern matching was introduced as a first iteration in C#7. But at that point, it didn't really make a lot of sense because it required a lot more code to express yourself. And the whole idea with pattern matching is that we want to write less code and express ourselves better and the code to make sense. But I'll show you how to not make sense in a moment as well. So pattern matching is all about allowing us to determine what things are. So in this case here, we could check if a fruit is edible, the color, if the puzzle piece is transparent, what order these things are in the poster, and so forth. I like to talk about this like matching on an attribute or matching on the type. And I'm not talking about the attribute in terms of what you decorate a method or a class with or a parameter, but an attribute as the color, for example. So in C#1 through 6, we've been able to do this as well. It's just a little bit different. You could say that I want to get the type of what I'm looking at, and I can compare that to a type of something, and then I can also check a property. If that property was only available on the subclass, I'd have to cast it myself. We've all seen code like this here. It's nothing wrong with it, but we could probably improve on this a little bit. One of the themes of improvements in C# is allowing us to write less code to express the same idea. So that's why in C#7 they require a lot more code to express the same thing. But this builds on to what's coming in C#8, 9, 10, 11, and 12, the improvements to pattern matching. So in this first iteration of pattern matching in C#7, there's quite a few things happening in here. The first thing is that we can use that type as the input to the switch. Inside the case, we can say if this is of my type that I'm looking for, I'm capturing this to a local variable. And I can then also use it as the concrete type without having to do any typecasting, which is quite powerful. But at the time that C#7 came out, I didn't use this a lot. But with C#8, we got this thing called a switch expression. This here is a little bit of a different way of writing the pattern matching, or using pattern matching. We can also use pattern matching with normal if statements and else if, but this is a really good addition to that. So I could say that this object, I want to create patterns for this to determine what this is. And I fill this switch expression with expressions, which is determining what it returns. So here's an example of that. I could say that, well, I'm looking for a specific type, and then it's going to return some data. It doesn't have to be strings. It's just a very simple example. But it could also return, could call a method that returns a complex object, it could return anything, right? And then the underscore, that's the discard. It's a way for me to say that I want to match on anything. I don't care if it's null. I don't care if it's even a fruit in this case. Like, I don't really care at all. So that's a quite powerful pattern as well. Now, there are a lot of patterns. So I said that C# 8 and 9 and 10 and 11 introduces some enhancements to pattern matching. That's an understatement. Because of course it's powerful enough to be able to say, what type is this? But I'd also like to be able to check on a couple of more things. So we can do a type pattern. So this is all the patterns available in C#. We're going to jump over to some code and explore this as well. We can also use something called a positional pattern. If we take an object and we can deconstruct that and pull it apart into different variables, we can also use that together with something that looks like a tuple. We can match on property values. We can match on exact tuple values or tuples or however you like to pronounce that. We can use relational patterns. So for example, let's say I want to find a person that's over 30 years old. I can use a pattern to express that. I can group these together to, for example, say people between 18 and 40 or 18 and 100. I can use OR to exclude elements. I can use parenthesized patterns, negated not, recursive patterns, and in C# 11 we also got something called a list pattern. So now you know all about patterns. No, kidding. We're going to jump into Visual Studio and actually look at how these are applied. All right, so before we look at the pattern matching part, I want to show you this object that I've created here. So this here is showing us a test result, which is obviously failed here. If we drill into this type, it's using this new thing called a record. A record is a reference type. It gives us quite a lot of things behind the scenes. It gives us value-based equality. It gives us immutability. And it also is defined by a primary constructor. Everything you use in the primary constructor will be available as a public property. So I have another example of this. I'm going to swap over to another IDE. Someone told me, you have to start using Rider because it's the best IDE available ever. Tried to do this in my workshop and it crashed all the time. It wasn't a very good idea. I blame the HDMI cable. All right. So I have this public record called person. It doesn't have to be public, but it is now. It has two properties available defined in the primary constructor. When I compile this, this will generate. I'm going to show you this here. This is looking at the lower level C#, and this is why I love Rider, because I can look at the IL, or the lower level C# that this decompiles into. So when you compile this record, it's going to create a public class called person. It's going to implement IEquatable. It's going to give you a constructor that lets you set the backing fields. It's going to give you the properties that are init only. You can only set them once, but they're public, so you can get that value out of the object. It's also going to implement toString to be able to give a nice representation of the object. It's going to also give you the operator overloads for inequality and equality, which is very handy. And if we scroll down to what IEquatable is actually giving us, we have this equals method that takes a person. This here lets you compare the backing fields of, for example, the name. You compare that with the other person's backing field of the name, which means that if you compare two reference types, if they're records, it's going to compare the properties. So for example, if we go back to this code here with the test result, if I do this twice, like this here, test result 2, these would be the same. This would yield true because they have the same values. Now I'm using datetime offset.min value here to make sure that they are in fact identical. A little gotcha with this is that if I do UTC now, or just now, they would have different ticks, so they would be unequal. Makes sense, right? Little side note. So that's why records are truly powerful. And they also give you a deconstruct method out of the box. So I could say that I could deconstruct this test into whatever the deconstruct method gives me. And if we look at what that means, is that it generates a method that has this annotation, or this notation. It's called deconstruct, that's required. It has a couple of out parameters. So it gives me a datetime offset, it gives me an integer, and it gives me a Boolean. So why is this important? Because now I could say, if we go back to that file, here we go. I could say I want to get the date, some integer, and a bool. And now I could deconstruct this object into these 3 different values. So why would you want to do this? This is important when it comes to pattern matching, because now I could use these positions to say that I want to find the integer that is greater than a certain value. So let me show you how to do that. We can do if test result, not that, test result is capable of being deconstructed into something where that integer is more than 10 and I don't care about the Boolean. This code makes a lot of sense, right? Everyone will know what this is doing. So there are a couple of things that are not good with this. There's no IntelliSense for what a deconstructs into. So if I know, I have to know exactly what this is called. So let's go into test result. It's called dateSense. I have to know exactly the casing and exactly the name of it, but I can use it as a named parameter. But this is a little bit problematic because it means that the code becomes a little bit unreadable. A better approach would have been to use this with some of the other patterns. So you'll see here now that you can use this with the if statement. But we can also say that I want to get a result based on whatever this test result is. I'm going to create one of these switch expressions. And I'm going to say that, OK, I want to find failed tests. Perfect, I can do that. But I can also say it has to be a failed test where the number of attempts are less than 10 and greater than, let's see here. I could do this. Actually, it has to be the other way around. More than 10 and more than 20. Sure, this makes a lot of sense. It does. Or less than 20. So I could do this to create a range, right? It's going to be quite smart to determining exactly what I'm looking for. So this here is a recursive pattern. It first checks that it's failed and that it can have a property that has this value. I could also say that I don't care which type it is, as long as this is of an instance, as long as this is of an instance, I can check that it has this property. So this will perform a null check and also perform a check on the properties. You can write patterns that are very confusing, and you can write them like this here, where they quite make a lot of sense. And of course, we could also use this with tuples and other types as well. But where it's powerful, let's say that I just want to use this. Like it's totally okay to use it to say, if it's failed, let's return to failed page. If you use it in ASP.NET. If it's passed, we're going to do something else. We're not going to throw a divide by zero exception. That would be odd. Okay. And now we can also say for everything else, we can just return 4. Right? But what's interesting with the discard, let's say that this here was from a method call. Like I have the object here, so of course I could access the properties of test result, in this case here, but sometimes you might not have the variable. And as I said earlier, test result here, we don't know if this is an object or not, so let's say here, I'm going to get the test date. I can do that because that's available on this type. Let's do toString. But if I do this and set it to an object, test date doesn't exist on the object. Makes sense, right? So instead, to get around that, I can say that, well, if it's a test or a result, I can use this as a local variable inside that switch instead, or inside that expression. It's quite powerful. So you can write patterns that are truly powerful, and you can also write patterns that make no sense at all. So like with any other feature in C# and .NET and other programming languages, just be very careful with how you use it and how you add it. It makes a lot of sense to use it to find a certain property value. Or, for example, in this case, we're just looking at the base types. Now, I do want to say this as well, because this is a question I get quite often. Surely enough, it's nice that I can say, if this is a failed test, and I'm looking for a particular property value, let's say number of attempts, has to be the number 10. But if I don't have this as a constant, how do I use this? You would have to introduce another approach and say you want to capture this when over here, when res dot number of attempts is more than 10, for example. You can do that as well. So if you introduce the when keyword, you've introduced a when expression where you can actually call methods. So while this will be very performant and compile time checks and so forth, this here will allow you to call method calls, which is one of the things I hear people ask quite a lot. Now in C#, 11 or 12, let's see here, we also got another way of working with patterns. So I have this list of people here, and I can say that if this data is empty, I want to do this. More frequently, you might want to say if it's not empty. So I can negate anything to say that it's not a certain thing. Obviously, you can negate anything like this, right? Put not in front of this, and who knows whatever that means now. So again, you can write patterns that are very confusing, but also in this case here, it's quite obvious. I'm looking for data that is not empty. I could also say that I want to get a result out of this here, to say that based on my data, or my list here, I'm going to create a list pattern, where I can say, well, if it's empty, I want to do something. But if there are elements, I want... That damn divide by zero exception. I'm going to blame the keyboard. Here we go. I could then say that this here is now going to say that as long as it has, or not empty, sorry, this matches empty. But I could capture that range to say that, for example, I'm going to show you an example here. I could say that the first element in this array, or list of people, has to have a name where the name is Filip. So the list patterns allows you to do, again, recursive patterns. I can say that this list has to be of some sort. Obviously, a list of people isn't where you would use this. You could use this to determine payload coming in from some external system where you're looking for certain bytes in the start or the end or whatnot. Because I could say that I don't care about what's in the middle. I want to make sure that the last element is set to an instance and that the name is, in this case, Elise. So again, you can write quite complex things here. I could also say, while there's something in the middle, it has to start with a Filip, it has to end with Elise, but I can also capture all the elements in the middle. Right? So you can use this to slice off portions of the array. Makes it quite powerful. So pattern matching is a great addition to the language, but it also comes with some responsibilities, right? We want to make sure that our code is readable, maintainable, and honestly fun to work with. Right, so let's jump back into talking a little bit more about what's been added in C# 10. So with the records being added to C# 9, they also introduce record structs in C# 10. If you want to do that, it's just about where they are stored. A gotcha with the record structs is that they are not immutable. Record classes are immutable by default, but the record structs are not. You have to also append the read-only keyword in front of it to make it a read-only record struct. Because why be consistent? They also made some other improvements. They introduced a global using directive and file scope namespaces. So you might have seen this. When I swapped over to writer, I had this namespace at the top here, but I don't have to wrap my entire class in this namespace. I can just declare the namespace for the entire file at the top. Again, this is to make it easier to review code, I guess. So when you submit a pull request, reduce white space, reduce noise. They also made some changes to pattern matching again to the property patterns, and did a whole lot of other improvements to C#10. So it's interesting to see that they're still adding important features, but some of these are less important than what we've gotten in C#7, 8, and 9. And the reason is that some of the improvements in C#10 is to make it better to write these minimal APIs. One of the features that they are allowing you to do is constant interpolated strings. So in this sample here, I'm creating an application name called Visma, and I'm just using string interpolation with a constant, which is something you couldn't do prior to C#10. A little bit more of an important language feature is when we're working with lambdas. So in this case here, this is C#8, where I'm saying that I have a function. It will return an integer. It takes a string as an input, and then it does something. But wouldn't it be nice if the compiler could just infer this for us? So it's going to infer the type. So with C#, actually this is C#9 even. So in C#10, you can then say var parse in this case here, and it will infer whatever this function is actually doing, which is nice. So you no longer have to explicitly say what kind of action or function you're doing, because the compiler will try to be very smart about understanding exactly what's going on. Here's an example of one of these minimal APIs, and also an example of one of the C#10 features. So you're able to now have attributes in your lambdas, so that in this case here, I have a very simple application that is mapping the root of the application to return some data. And I can say that it should get that data from the content header, but in previous versions of C#, we were not able to do this. And another improvement that they're making in C#11 is that they are allowing you to have default values in lambdas. So I could say that if you don't pass an ID here, the default is 0, for example. Which is also one of those features that I don't understand why it took so long time to add this to the language. Now, with C#11, which is the current version, this was released in November, and we're not going to have much time to talk about C#12, and there's a reason for that. They tend to always talk about all the amazing features they are going to add to the language, and then 2 days before they release it, they just scratch all of it. That makes my life very hard. So, I'm going to talk a little bit about C#11 instead. We looked at these patterns. These were added to C#11, where you can match on the contents of a list. You can slice off portions of a list. You might not know this, but the syntax that I used here, this here is the range syntax, which is also something that you use to slice off data in an array. So if I have an array of bytes, for example, I can say that I want to slice off portions of that. I have an example of that in just a moment. So we also got more patterns improvements in C#12 as well. Or we are going to, I can assure you with that. They're also introducing name of parameter. And finally, they're caching the delegates for static method groups. Now, this might sound silly, but this is a huge performance hit in older versions. So it's quite important. If you use this, it's going to be quite performant. I showed you the required properties. And what's interesting with the required properties is that you can now write a little bit more fluent code. There's nothing stopping you from enabling this language feature of nullable reference types, because you can now go ahead and enable that and set all your properties to required and just fix some of the places, rather than having to introduce a constructor all over the place. More keywords is better, right? So this here is a required string called name. There's another language feature called raw string literals, which I have an example of soon. There's something called static members and interfaces. There's also UTF-8 string literals. So example, a lot of the data that we're getting from the web is all UTF-8. But by default, or C# is UTF-16. So all the data that you work with that's coming in from the web, you have to convert that into UTF-16. And then if you want to do processing with UTF-8, there's a lot of memory that you have to shuffle around, and it's just a little bit not very performant. So instead, they allow you to add the U8 at the end of a string, and this will give you a span of a byte array, or a read-only span of a byte array, actually. And this will let you do processing on this string, or this byte array. There's generic math. There's generic attributes. So this is also one of those features. If you've been working with older versions of ASP.NET, you might have introduced your own attribute class. And you've never been able to do a generic attribute up until C# 11. Now, finally, there's a thing called parameter null checking, which they withdrew. But some of you, if you haven't been keeping up with the language, which why would you be here if you have? So if we go into, let's go to this class here. Now, instead of me having to perform this check here at the bottom, what they suggested was that, why not use double bangs? And it will automatically perform a null check and throw an exception in your face if this was null. Imagine how many people like this idea. They refactored a whole lot of projects internally, or actually on GitHub, so it's not internal, but a lot of the internal projects that have people on Microsoft working on them, they refactored a whole lot of things to use this. While it did reduce a bit of code, it also adds some noise. Having exclamation marks all over the place, it's not very readable. It's not very nice. So, due to a lot of community backlash, they had to remove this language feature. Which is nice. Which is one of the reasons this being open source is a great idea, because we can participate in the discussions, and we can give ideas, or we can just tell them things we don't like. And they might listen, and they actually did in this time. So the list patterns are quite complex as well. As I showed you earlier, you can grab the middle elements, and you can use that then inside the right-hand side of that expression. We can make sure that a second element is of a certain value. We can say that I don't care about the start of the elements. I just want to get all of it. So we can do quite a lot of things here with that list pattern. The other feature that is important is raw string literals, where I could say that I'm using 3 double quotes to say that I'm going to write some code here. Now with XML, I'm not getting any syntax highlighting, but I can use the string interpolation here as well. If I jump over to writer, I think I have an example of that here, where I use this with JSON. So I'm going to deserialize some JSON. I'm using the raw string literals to say that here's my JSON object that I've defined inline, and I'm getting some syntax highlighting. It's also going to remove the white space at the front here. So that's a quite nice feature. Now, I've mentioned the raw string literals, or UTF-8 string literals. In this case here, I take my name, I convert that into a read-only span of bytes, and then I can say that based on this payload, I want to be able to then grab the index of the first space, where the index is also a UTF-8 space. And then I can use the range syntax together with slicing to say that I want to get my first name and the last name. Why is this important? Because this here is allocation free. It's a little bit of a lie, because it does allocate one variable on the stack here to hold the reference to that array or that span of bytes, but it doesn't have to do any copy of my content, which is very performant. And it's very much better than having to copy arrays over all the time and do some more processing. The alternative, and the way that I used this before, is to use link, which is not the most performant thing to use for something like this. They're also introducing a concept called static members in interfaces, or static abstract members in interfaces. We've always been able to do static in interfaces, but it just never gave us any warning. So here I have a static T inside my interface. There's no warnings that I haven't implemented this on my class. So again, why not just add another keyword to this to actually enforce us to implement what the interface dictates? So here I add the abstract keyword, and now it's going to tell me that you have to implement this. I would have assumed that you had to previously as well, but for some reason they didn't enforce that. So that's all there is to C# 11. Now, the question is, what's next? We have another few minutes to talk about the upcoming features. And I have a link here that's showing all the progress of all the different language features of .NET and C#, or actually in C#. They have a GitHub page where they're doing all of this in the open. They take comments from users, and they want to get the community participation so that they know that they work on the right thing. One of the things they want to add is a concept called a primary constructor. This looks very much like a record. It's a little bit different, though. So with records, you use a concept also called primary constructors, which is very confusing because they're very different. They are fundamentally different. Notice how I have a lowercase name here. That is to indicate that this is in fact not a public property. Now, it doesn't matter that I have lowercase or not. It's just this is a field in my class. It's not going to create a property behind the scenes when this is compiled. And that's where it's different from records. Records, the primary constructor, introduces a public property, but this does not. Slight difference. So if you want this to be publicly available, you'd have to first introduce that as well. You have to introduce it, and then you can use the primary constructor value to set it. And you'll see that if we decompile the application, what it's doing is that we got this constructor, and it's simply setting a backing field. So it's a little bit different from the record. But this is not released yet, so who knows? They might change it. So take this with a grain of salt. And then what they also want to add is a default for or optional parameters in Lambda expressions, or also known as default expressions. It's funny when you read the documentations, even the official Microsoft announcement of this, they talk about this using two different names. But it's the same language feature. So again, with the consistency. But they'll get there. Once this is released in November, we'll know the name, and hopefully it will make it into the language. Because for minimal APIs, where I set up very small ASP.NET APIs in a small console application, which can then later grow into something bigger, this is a nice addition. Means I don't have to introduce more endpoints. I can rather just add default parameters. And don't use null as a default. We've already covered that. So I could call this with or without a value, doesn't really matter, and this would print my name to the console. The final feature that they have officially said that they are getting into C# 12 is the way to alias pretty much anything. This is an interesting language feature. So I'll go into my class and I'll say, I want to use the name point. And whenever I call something a point, this should refer to the tuple or tuple. Now, we haven't talked about this, but in C# 7, they introduced the concept of tuples, or tuples, whatever you want to call it, as a first-class citizen in the language. This introduces a container of sorts of just fields on a little class. Very handy, very useful feature. So now if I do this, I'm going to say I want to use the name point, and whenever I call that, I'm going to get a tuple with two values, or two fields. So I can use this as an input parameter. And if you put global in front of this, it's going to be globally available throughout your entire project. Quite a useful feature. But then again, there's so much added to C#, and there's probably a little bit of confusion as well as to where the language is going. But just because they're adding a language feature doesn't mean that we have to jump on it and use it. It's very nice to be able to come from F# or Kotlin or Java and find that, oh, I have pattern matching available in C#. I can somewhat take my code and translate that into C# if I need to. Actually, I don't personally translate any code anymore. I just paste it on a very popular website, and something just pops up and it just works. I'm guessing everyone's getting a bit tired of talking about ChatGPT, so I'm not going to do that. But the language features that have been added in C# so far, they feel like they are familiar to a C# developer. They have a purpose. We can obviously misuse all of it, but we should try to avoid doing that. If you've liked this, I have a lot of courses on Pluralsight covering language features of C# asynchronous programming, which I also have a session on at 3 o'clock today. But there's a whole lot of things to check out if you'd like to. Again, I hope you've enjoyed this. Thank you so much for coming. Please vote on your way out. If you didn't like this, send me an email and forget to vote. I'm kidding. Enjoy the rest of the conference. Thank you so much.